Hello class, in this video we're going to look at the periodic families that are on the periodic table. So first thing, the periodic table is arranged so that elements with similar properties fall into the same group or column. These are the ones that go up and down. So there's 18 of them, and we're just going to take a look at a couple of those different families. And the reason why they're called families is because these elements share similar properties. They have a lot of the same type of properties, and we'll look at what does that mean throughout this video. So the first group or family that I want to look at is the noble gases. This is group 18. First, they are all gases and they are very unreactive. They don't really react with anything at all. And what I want to know is, well, why is that so? Why is it that they don't react? And the answer is that they have full outer shells. If we look, this right here is the electron configuration for helium 1s2. That is a full shell. Actually, they have complete full shells in every energy level. If we look at the next one here, this is neon, and we have the first energy level and it's completely full. The second energy level, the 2s, and it holds 2 and it's full. 2p, and that holds 6 and it's full. We also look at the next one down here, argon. And argon has the first energy level, which is full, second full, and the third energy level here is also full. And that makes it a very stable electron configuration, and it doesn't need to react with anything else to reach this. So we see that elements want to have a stable, completely filled shells, just like the noble gases. And this is called the octet rule. The octet rule just states that atoms gain, lose, or share electrons until they are surrounded by 8 valence electrons to achieve the same number of electrons as the noble gas closest to them in the periodic table. They all want to have this S2P6, whether it be 2S2, 2P6, or 3S2, 3P6, 4S2, 4P6. They all want to get to this. And the way that they do it is either by gaining, losing, or sharing electrons to get to 8 valence electrons. So this really causes the elements to be reactive. And since the noble gases already have this electron configuration, they're not reactive at all. So the next group I want to look at are called the alkali metals, and this is group 1. This is the very first group on the periodic table. And they're silver, they're metallic, they're soft, and they can be cut with a knife. And usually when we think of metals, we think of something very, very hard. These metals are actually really, really soft. You can just cut it with even a butter knife can cut a lot of these metals. And here are some examples of the alkali metals, and you can see they're stored in some type of liquid. The liquid that they're stored in is an oil, because they are very, very, very reactive, and that's the next slide here. They're extremely reactive with nonmetals and with water, so they're not really found in nature as free elements. They're usually in some type of compound. So why are the alkali metals so very reactive? They have to be stored in oil. They can't be around water. I mean, they are that reactive that they can't even be around water. They'll start reacting. So why is it? And what we see if we look at the electron configuration, and we have a couple here, is that they all want to lose an electron to have a completely filled shell, like the noble gases. So if this electron configuration, this one particular here, lithium, if it loses this one electron, the 2s1, this particular electron, that will fade away and will be just with helium, and it would have a full outer shell. Same thing here, just one electron. So it's so very close to having the same electron configuration as a noble gas, and that's what's going to make it so very reactive, is that it can lose one electron and instantly now it has the electron configuration of a noble gas, which is what they want. So why lose rather than gaining? How do you lose electrons and then get a full outer shell? Well, if we look at this, these electron configurations, they need an electron configuration of S2P6. Well, for this element here to get to 2s2, 2p6, it would have to gain another 7 electrons, 1 on the s, and then a 2p and 6 of those. So that's 7 electrons that it would have to gain, and that's very hard to do. Where if it just loses this particular 1 electron, just gives it away to another atom or another element of some sort, then it will have its noble gas configuration, and that's what it wants. So it's much easier for this particular group of elements just to lose an electron rather than try to gain. And actually this is how all metals are going to do. All metals are going to lose electrons to get to a noble gas configuration, and the nonmetals are actually going to be the ones that are going to be gaining or sharing electrons to get to that to get to the noble gas configuration. So the next group I want to talk about is the alkaline earth metals. This is group 2. These are a little harder, denser, and have a higher melting point than group 1, the alkaline metals. They're also still very reactive and not found in nature free. They're usually in a compound of some sort. So why are the alkaline earth metals so reactive? Well, they also want to have a complete outer shell. And we look at here, we have these electron configurations. We have a 2s2, 3s2, 4s2. So all they need to do is just lose 2 electrons, and they would have a noble gas notation or noble gas configuration here. All they need to do again is just lose 2. So it's very, very reactive and very willing to give up those 2 electrons so it can have that filled outer shell. The next group I want to talk to you about is the transition metals, which is the entire D block. That's groups 3 through 12. Just real brief, they're all metals. Some are reactive, some are not. We're not going to be dealing with these as often as we are going to be dealing with the S block and the P block, the main group elements. So the last group I want to introduce to you is the halogens. This is group 17. This is the one right before the noble gases. So they are very, very reactive nonmetals. Before we were talking about the metals and how reactive some of those are, this is the most reactive nonmetals are the halogens. And that reactivity comes because they're so very close to the noble gases. They're only 1 electron away from having a complete filled outer level or complete filled outer shell. So these elements, and just like all nonmetals, are going to want to gain electrons to get to a filled outer shell, as opposed to the metals, which are going to give up electrons, just give them away to other elements. These are the ones that they're going to be giving them to. The halogens or any nonmetal is going to take or gain electrons from the nonmetals, or they may share electrons between 2 nonmetals. They can also share to get these full outer shells. So that's what makes the halogens so very reactive, because they only need to gain or share 1 more electron to have that full outer shell, and all atoms want that full outer shell. So that really completes our video on the periodic families. I'm also going to have a video for valence electrons and how is it that these atoms gain or lose or share, in what ways, and why do they become and how do they fill that outer level, is what we're going to look at in later videos. Please bring any of your questions to class, and I will see you then.